Hello, everyone, and thank you for joining us. Let's just go with a round of introduction first, and then we can introduce the topic of this webinar today. So I'm Giulia, nice to meet you, and I'm the product manager here at Canonical for all that concerns big data and analytics of big data. And I'm here joined by Paolo. Paolo, do you want to introduce yourself?
Sure, I'm Paolo. I'm a software engineer at Canonical for the past 3 years, and I had almost 10 years of experience working with big data both in industry and academia.
Bikalpa as well is joining us.
Hi, it's me, Bikalpa, and I've been working in Canonical from the past 2 years in the Spark team. Nice to meet you all.
And Alex as well.
Hello everyone, I'm Alex. I've been at Canonical for the past year and a half, and I'm a former data scientist in the healthcare industry.
Alrighty, so thank you all. So what you see here is part of the Spark team here at Canonical, working on big data overall and analytics of big data. So today we will be talking about what you see. So the title is an open source data lakehouse architecture with Spark and Kyuubi, and we'll offer an engineering deep dive. So let's look at the agenda and the topics we will talk about. So first of all, we will talk about what we call the charming components, so the components that make up the full solution. And then we will have a higher level look at the overall solution, what it's made up of and how it works in general. We'll look at the enterprise services that we can offer on the solution. And last but not least, we'll offer a very fun or in your lab environment. All right, so let's dive into it. So I'll give it to Alex for the charming component.
Sure. So let's get started on the first part of the data lakehouse, Apache Spark. What is it? What is Apache Spark? Simply put, it's the leading data processing framework. It provides an interface to run workloads on multiple nodes in a highly performant manner and with fault tolerance out of the box. It can be used to run batch processing jobs, interactive queries, or even drive real-time analytics. And since 2018, we can even run it natively on top of Kubernetes, which brings us to the first part of our offering, Charm Apache Spark. On the next slide, please. So here at Canonical, we built our own spin of Apache Spark called Charm Apache Spark, designed exclusively for Kubernetes. It's a collection of artifacts, charms, rocks, snaps, to run production-ready Spark workloads on Kubernetes. The entry point to the ecosystem is the Spark client snap on the right-hand side of the screen, which takes care of configuring service accounts on a Kubernetes cluster to run Spark jobs. The service accounts can then deploy Charm Apache Spark rocks, which are OCI-compliant images on the cluster. From this point, you can submit Spark applications using the Spark client snap to the Kubernetes cluster, which will take care of creating a driver pod, which in turn will create the executor pods to handle the application code. The Charm Apache Spark solution also includes additional charms. For instance, we offer a charm history server, an integration hub, and a new charm we'd like to present to you today. Moving on to the next slide, then, what is Apache Kyuubi and what purpose does it serve? So even if we made it simpler to deploy and operate Spark on Kubernetes, the ecosystem remains complex to use. There is a need for a middleware to hide the complexity away from the users and also to provide additional features on top of it. Apache Spark is one of those solutions. Its main value proposition is to act as a gateway to Apache Spark by offering a highly available interface to query datasets from multiple sources. In addition, Apache Kyuubi supports multi-tenancy setting through an authentication layer, where each tenant gets a share of the total computing capacity without hoarding all the resources. Apache Spark extends the concept of the Spark context to what is called the Kyuubi engine, and each engine can be attributed to one or more tenants. Last but not least, another big part of the value proposition of Apache Kyuubi is the addition of new connectors for other data sources than what is currently used, oftentimes used with Apache Spark. So for instance, Apache Kyuubi makes it easy to interact with Hive, Iceberg, or Delta tables. Moving on, how do we integrate Apache Kyuubi with our current offering to create the open source Charm data lakehouse? So even if Apache Kyuubi streamlines data processing on top of Apache Spark, deploying it, managing its lifecycle can still be tricky. So by leveraging Juju and Charm technologies, we created a new Charm for Apache Kyuubi to simplify its deployment on Kubernetes environments and how to operate it. At its core, a charmed operator includes both the workload, that means Apache Kyuubi itself, and the operation code to operate it. This means that the most operations you would want in such a data lakehouse are just a few integrations away, and that the solution is fully modular. And what we mean here by integration is that you don't have to write anything yourself, since the integrations and the domain logic are part of the operation code bundled within the charm. So I'd like to give you a couple of examples, practically speaking. If you want to add observability to your data lakehouse, you just need to integrate the new Kyuubi charm to the Canonical observability stack. Then it will send logs and metric to Loki and Prometheus. Or let's say that you want to enable TLS to encrypt traffic between the Kyuubi server and the client application. Then you just need to integrate the two charms together. When you integrate two charms, the operation code in both charms takes care of exchanging the necessary information. It takes care as well of updating the workload configuration, meaning writing the certificate on disk and so on. It restarts the service and can even notify other related applications as some kind of chain reaction. This means that if I renew the certificate on one hand, I can notify the client application on the other that there is a new certificate to use. Since we were speaking of integrations, let's move on to the next slide where we'd like to share with you this table. So this is the list of the Charm integration we currently support with our new Charm for Apache Kyuubi, thanks to the whole Charm ecosystem that we have at our disposal. As you can see, there are already quite a few of them, but this list will definitely grow as we have more integration coming next, such as, for instance, ways to provide more fine-grained access control and authorization mechanics. But a data lakehouse platform built using this solution would not be limited just to those items, because on top of those, there are already several ways that we can use Spark as you know it to consume data from other sources and then store them in Hive tables, for instance, and then they can be queried using Apache Kyuubi. This brings us to our next speaker, Paolo, who will explain what a data lakehouse is.
Oh, thank you, Alex. So first of all, what is a data lakehouse? So a data lakehouse is a centralized repository that is designed to store a large amount of raw data in its native format. Unlike a classical data warehouse, which stores structured data, a data lakehouse can accommodate various types of data, structured, semi-structured, or unstructured one. This characteristic makes it ideal to handle the diverse and growing volume of data generated by modern applications, such as IoT devices, streaming data, or data coming from social media. But the data lakehouse is not just a pure container of data. It serves also different purposes. For example, it can be used to run business analytics. It can be used to to run analytics and also to consume, to train our machine learning models. The overall solution can be divided into different layers. The layer on the bottom is the disaggregated object storage that is responsible for the storage of the data in different formats and different size and at different rate. On top of it, we may need a framework to process, both to ingest and consume those data in a fast way. In order to do so, we need a distributed and parallel processing framework that is able to handle massive volume of data. On top of it, we also need a way to query those data in a structured format, and then also to analyze those data with modern analytics tool. In our scenario, these different boxes can be represented by different components. So as disaggregated object storage, we can use any S3 compliant storage. It could be AWS S3, Ceph, MinIO, or for example, also Azure blob storage. Instead, as distributed parallel data processing framework, we can use Spark on top of Kubernetes to scale up and scale down our processing needs. As query engine, we can use the presented component Apache Kyuubi that is leveraging the power of Apache Spark to basically execute queries on top of the object storage. And in order to provide analytics, we can use like Jupyter Notebook with Spark context inside to perform our analytics in a distributed fashion. Given that, now we can have a look on how the benefits of this architecture, both in terms of capabilities and services available at Canonical. I will let the stage to Julia to give you a brief introduction to that topic.
Yes, thank you very much, Paolo, for the introduction. And so I'm here to talk about the benefits of the solution and then the services that we offer overall on the data lakehouse. So first of all, as Alex and Paolo mentioned, at Canonical, we very much focus on building a cloud-native data lakehouse. And the reasons for doing this are various. One very good reason for sure is convergence, for why you might want to use a cloud native solution like the one we provide. So having a consistent user experience across multiple clouds and different environments is definitely a good reason to choose that. Future-proof is very much important as well. At Canonical, we very much focus on long-term support with a long-term commitment. So that's another very good reason why you might want to work on our version of data lakehouse. Another very good reason is disaggregation. And this is because by disaggregation, I mean the possibility to spin up and spin down resources as needed. And obviously the fact that we are using cloud-native technologies allow us to scale on demand and also optimize cost, of course, and this impacts storage as well. Then another very good reason going forward is performance. Of course, we want to allow enterprises to run on the environment of their choice with the hardware of their choice, so to run workloads on dedicated hardware. And finally, sovereignty is a very good reason, last but not least. So you can spin these workloads on particular parts of the technology or on premises or on dedicated hardware where you definitely have certain properties with absolutely no lock-in. Because we, as outlined before, we are working with fully open source technologies. And of course, these allow enterprises to be compliant with, local regulations when it comes to, the locality of data or similar things. So these, of course, are all very good reasons to work on a cloud-native data lakehouse that I'm sure you're all aware of. Then let's look at our services. So first of all, we do offer hardware and software design. That's not a subscription-based offering, but more an engagement-based with our field engineering team. And then when it comes to security maintenance, we offer that on with our base level of services, which is called Ubuntu Pro. But if enterprises want support for break bugs, fix, and incident management, then we do offer Ubuntu Pro Plus support, whether it's ticket or phone support with defined SLAs. However, if enterprises need a more tailored support that's not just backed up by ticket and phone, we also offer firefighting support, which is basically screen sharing with a dedicated person that solves your specific tickets. Then we also, if you want to, give away the hassle of managing your data infrastructure, then we offer managed services with our managed services team, which operate on the infrastructure using our automation, and that's done. And that the service offers monitoring, patches rollout, deployment, and the rest. So you can very much give away the struggles that managing an infrastructure bears, and offload that to our team and focus on your core business and your business application. So what brings value to users. All right, so let's move on, and let me give the stage to Bikalpa, who's gonna show us a very nice demo of what we've introduced so far. So stage is yours, Bikalpa.
Thank you, Julia. Hello again. I'm back with a demo. Next slide. So in this demo, we are going to see a full pipeline from the data ingestion all the way up to data analytics using charmed solution, including like charmed Spark, charmed Kafka, and charmed Kyuubi. So in the ingestion, we will see how data can be ingested into the Kafka topic. And for Kafka, we will use charmed Kafka. And we will see how these messages can be read into Spark using Spark streaming. And for Spark, we will use charmed Spark. And in the storage layer, we will see how the process data can be stored in S3 compliant storage, as well as the meta store in PostgreSQL. And finally, we will see how we can leverage the powers of Apache Kyuubi to make queries on that data and then perform analytics on it. And in the end, we will also see how we can integrate Canonical observability stack to monitor the situation of our cluster and metrics. So before we start, I want to show how we can set up the environment for running this demo. And I want to explain some of the technologies that we use today for this demo. So the first thing we will use is micro-K8s. So since Apache Spark as well as Apache Kyuubi are meant to be run on top of Kubernetes, we will need a Kubernetes cluster installed in our machine. And for this, we will use micro-K8s, which is a very simple production-grade conformant Kubernetes cloud that can be installed with Snap in our Ubuntu machine with a very ease of use. And for the S3 compliant storage, we will use the next technology called Minayo. So Minayo we will use in order to store the data in the S3 buckets, and Minayo is fully S3 compliant. And we use this technology because it is available, by default in the micro-K8s cloud. We can simply enable the add-on and it is ready for use. And it also, you can run this in your local machine and have a fully S3 compliant object storage at your hands. The final technology we were going to use is Juju. So Juju is an open source orchestration engine, and it is meant for enabling the deployment, integration, and lifecycle management of charmed applications. Juju can run on top of VM as well as Kubernetes, but today, since everything we deploy is going to be on top of Kubernetes, we will see the special uses of Juju on Kubernetes. It can also be installed using Snap. So let's see how all of these can be installed on an Ubuntu machine. First of all, we will install micro-K8s using Snap. And then we would export the kubeconfig file. After that, using kubectl, let's see the different namespaces on our cluster, we can see Kubernetes is installed. After that, let's enable a bunch of add-ons like DNS, RBAC, and MetalLB, which we will use for DNS, role-based access control, and load balancer, respectively. And when we do microkate status, you can see microkate is running. Let's enable Minayo. As I said, Minayo is fully S3 compatible object storage. And after installation, you can see that there is a service called Minayo created. Let's try to export the S3 endpoint, the S3 access key, and S3 secret key into environment variables so that we can reuse them later. Once we do that, we are going to install an S3 client. And for that, we will install AWS CLI, which can be installed using a snap as well. After that, we will configure the CLI with the endpoint, with the access key, and with the secret key. After all these, we will be able to create a bucket called a Spark in our S3 storage. And finally, we will also create a path called the Spark events inside that bucket. We can verify this with AWS S3 ls command. Now, finally, let's install Juzu using a snap. Once Juzu is installed, Juzu is intelligent enough to recognize the microkits cloud that has been installed in the machine, as you can see in the screen. So let's bootstrap a Juzu controller using Juzu Bootstrap. And finally, we have a working Juzu controller, and we can begin deploying apps using Juzu. So now, coming to our pipeline, let's start in the first phase of our pipeline. In this phase, we will generate some Kafka messages and then ingest it inside the Kafka topic using Kafka. And for Kafka, we will use Canonical charmed Apache Kafka. Let's see this in action. First of all, we are going to add a module called Kafka, and I will create a few more screens so that we can see more data. On the left-hand side of the screen, we will see the Juju status of the module Kafka, and also different pods that are created in the namespace Kafka. So now, in order to deploy Kafka, we can use Juju deploy command and then deploy Kafka Kates app. And as easy as that, in the left-hand side, you can see a new application being created. After you wait for a bit, you can see an application called Kafka has been created. Also, a pod has been created in Kubernetes cluster. It says missing Jupyter, so let's deploy Jupyter for it to work. And once Zookeeper pod comes up and running, let's integrate Kafka with Zookeeper. This will effectively set the Zookeeper credentials to Kafka, and Kafka will start working. So now we want to produce some messages, and for this, we will use a test app called Kafka Test App and configure it as a role of a producer to generate some dummy messages for us. Once we deploy this and wait for a bit of time, we can see the app deployed in the left-hand side. Finally, let's integrate this application with Kafka such that it sends those messages to Kafka topic. And wait for everything to go active. To verify that the messages are indeed being created, let's see inside the logs of the producer application. And as you can see, new messages are created every few seconds. These are ingested into Kafka. So let's move on to the next stage of our demo. In this phase, we will write a Spark job that can read those data or those messages from a Kafka topic and then process it and finally store it in a storage layer. I want to show you a sample Spark job that can do this. So in this job, we are first creating a Spark session, and then afterwards, we read data from Kafka and store it in memory. And the third stage, we perform aggregation on that data, and finally, we store it as Hive table. So let's see this as a demo. For writing the Spark job, we don't need to write this Spark job right away because we have an application called Spark Test App that has already written this Spark job for us. So as you can see on the screen, we can see in the repo the data being read from Kafka, the operations being done in the data, and finally the data being written to the destination. And also, this charm does the job of doing a Spark submit to actually submit this Spark job. So in order to deploy this app, we'll use sudo deploy again, specify the app, and then provide a bunch of config. But let's wait. Let's try a different way. In order to deploy this, let's use Juzu Terraform provider. In this screen, you can see a Terraform module where whatever we do using sudo deploy, we can do equivalent of this by simply declaring a resource called Juzu application. There you can see the Spark test app. We specify the config. We also specify the integration effectively between the consumer and the Kafka application. And then you can also see like a variable called model, which we will provide externally. And finally, you can see the Terraform Juzu provider declaration there. Let's save this file and see the Terraform variable. Here we have provided the value of model as Kafka because this is the name of the model as well as name of the namespace we are going to create a resource on. Let's install Terraform using snap. Once Terraform is installed, let's initialize it. And now we will apply the Terraform module using Terraform apply and providing the variable file. In the zone plan, we can clearly see that an application is going to be created as well as an integration is going to be created. After we verify this, let's type yes. And Terraform apply will be successful. If you see on the left side of the screen, the application has already been deployed and the pod is also running. And it will say missing integration hub relation. So now we'll try to understand what integration hub actually is and what role does it play in our demo. So the integration hub is an application, or let's say a Juju charm, that will provide the Spark consumer applications with a Spark service account, a service account that is able or like have enough privileges to run the Spark job. That means to create a pod, to read the secrets, etc. On top of it, it will also provide the Spark consumer applications with a bunch of Spark properties that enable the Spark consumer application to run the Spark jobs. These properties are dynamically created by the integration hub by relating with other charms such as the S3 integrator, the observability bundle, the Azure storage integrator, etc., and then create Spark properties corresponding to them. Now let's proceed to deploy integration hub in our cluster. Next slide, please. Okay. To deploy the integration hub, we will use the Spark Terraform module. And in the Spark Terraform module, you can see a bunch of applications are already defined here. For example, the Spark history server, the PostgreSQL application to be used as a metastore, also the Spark integration hub, and also the Spark, the S3 integrator app, which will be used in order to deploy or use the S3 bucket we created earlier. So now I have already cloned the repository in my local machine. And you can see the same structure that you see in the repo in my local machine as well. So now let's initialize Terraform again. And now let's see the Terraform variable files that we need for this bundle. If you see in the Terraform variable files, you can see we specify the S3 endpoint, the bucket where we are going to store the data files, also the model where we will create these resources, the storage backend, which is S3, the admin password for the Kyuubi, which we will come later, and whether to deploy the canonical observability stack. You can see the S3 endpoint is same as the endpoint that we created earlier. So now let's apply this Terraform module and specify the Terraform JSON file. If you can see the plan, it plans to add a bunch of different applications and integrations. For example, it plans to create a module called Spark, different applications like S3 integrator, and most importantly, the Spark integration hub, because that is what is required by the stream consumer application. If we type yes, we can see that the resources has been created. On the left side of the screen, let's try to see the different models in our Juzu cluster. We can see a model named Spark is already created. Let's switch to Spark and see the status of this model. We can see that different applications are being created and deployed in this model. Let's fast forward until the application is complete, or the Terraform apply is complete, and we can see the S3 application is in the blocked state asking for access key and secret key. Let's provide them. We already have these as environment variables from the earlier stage. We can simply provide them using Juzu run, and then the charm action called sync S3 credentials. Provide the access key and secret key from the environment variable, and press enter. Once you do this, the cluster will slowly transition itself into active and idle state. Let's wait for that. Yeah, finally, we have a fully active and idle cluster where, for example, we have integration hub, we have Metastore, which is Postgres Metastore, we have S3 application, all working. So now let's switch back to Kafka. Our application is still waiting for the integration hub relation, right? So let's offer that relation from the Spark model and also offer Metastore relation. Let's switch back to Kafka and consume that relation. After that, we can simply integrate the stream consumer with Metastore and with integration hub. And just like that, the Spark consumer will transition to active idle state. So finally, the final switch is to start the process. That will effectively start the Spark job for the data to be read from the Kafka topic and processed and written to S3. To verify it, we can see the server logs inside the Spark, the stream consumer. And also we can verify it by looking at the pods in the Kafka namespace. We can see the Spark executor pods have already spawned. And on the right side, if you see closely, it also shows you where the data is actually stored in the S3 bucket. Let's try to see what's inside that S3 bucket. As you can see, there's a table called relation 12, and inside it, the data files are already started being stored. And this is the power of Charmed Apache Spark. So now you already saw the demo. The Spark job has started. It has started, processing the data and writing the data into hype tables. But how is this magic possible? This is where Charmed Apache Spark chimes in. So Charmed Apache Spark, or especially the integration hub, when the consumer applications are related to it, it automatically creates a Spark service account and also stuffs that service account with a bunch of Spark properties that enable the Spark consumer application to run the Spark jobs. Let's see this in action. So as you can see, on the left screen, we will see the state of the the Spark model. And here you can see the integration hub. Let's try to see the different relations in this model. If you see closely, you can see the integration hub is related with S3, and this will effectively make the integration hub create a bunch of Spark properties related to S3. Let's switch back to Kafka model. And let's see the different relations we have in this model. And as you can see, the integration hub is then in turn connected with the stream consumer. And that means the integration hub will automatically transfer all those Spark properties for the streaming consumer application. So now to see what are these Spark properties, let's install a client called a snap called the Spark client. And using Spark client, let's try to list different service accounts. So these are the service accounts created by Integration Hub. As you can see, in the Kafka namespace, we have a new service account being created. Let's try to see what are the Spark properties associated with this service account. Using the same snap, we can see a bunch of different Spark properties there. For example, the Spark property is related to where the event log will be stored, or for example, how the Spark consumer application can interface with S3 file system, and a bunch of other Spark properties, for example, where the warehouse directory will be, what will be the service account or the namespace that will be used by the pods. All of these are automatically created by Integration Hub and then provided over the relation to the Spark consumer application, or in our case, it's the stream consumer application. And then stream consumer application with just that relation is able to run Spark jobs out of the box. Let's go to the next slide. And now, since we completed the streaming phase, where, for example, using the Spark, charmed Spark, we wrote a Spark job, ingested data from Kafka topic, and then finally written that data in the storage layer. Let's go to the storage layer. So when we run Spark SQL, when we write data in the storage layer, so the raw data will be written in the object storage. For example, in our case, it is Minayo, where it can be S3, or for example, Azure Blob Storage, etc. And the data catalog and the metadata will be stored as Hive Metastore. And for us, we use PostgreSQL in our bundle. Next slide. And as you can see, we did deploy PostgreSQL and S3 integrator already because they were part of the same bundle that we deployed using Terraform. So this also completes the storage layer. Let's go to the next layer, the serving layer. If you see the Spark model, you can see there is application called Kyuubi in there. And if we see the relations, this application is already integrated with certificates, also with Integration Hub. It is related with Postgres over two relations, one for authentication database, or AuthDB, and one for Metastore. And finally, it is integrated with Jupyter for HA. As you can see, there are like 3 units of Kyuubi there in HA setup. So all of these are automatically deployed when you deploy the bundle using Terraform. If we run data integrator get credential, you can see different credentials that can be used in order to connect to this Kyuubi cluster. And then the data, the endpoint provided there is a load balancer address that will effectively distribute your load among the different units of Kyuubi. And you can also see the TLS chain. That means TLS is enabled by default. Next slide. So finally, we also saw Kyuubi deployed, and it is already integrated in this ecosystem as part of the same bundle. Let's see how we can utilize Kyuubi endpoint to make analytics query. So as you can see, we have a JDBC URI for us to be able to connect with Kyuubi and TLS CA. So since TLS is enabled by default, we would need the CA certificate in order to be able to connect to Kyuubi. Let's write this to our file. And then we need to import this into our trust store. For that, we will use keytool command. So using this command, let's import that CA certificate into our local trust store called truststore.jks. You can see it here in the local system. And now we can use either the Beeline CLI client, or we can use a GUI client called dbeaver. Let's install dbeaver using Snap. So once dbeaver installs, let's open it. Let's create a new connection inside dbeaver. Let's choose Apache Kyuubi and choose URL. The JDBC URL is obtained from data integrator. And now connect to default database with SSL equals to true, provide the trust store password and the location of our trust store. For the username, it is available as an output of data integrator, and the password is also available there. Let's test the connection. And yeah, the connection is successful. Let's see what data it does actually have. There we can see relation to a table. Let's try to run some SQL queries. A very simple SQL query at first. We want to select the first 100 rows from this table. Let's run this. And you can see the first 100 rows, where, for example, you have the starting window, the ending window of the timestamp, and also the producer and the number of count of the messages. Let's try to write a bit more interesting query, where we want to do aggregation to find the total number of messages between two times, 533 and 535. Let's run this aggregation query. And you can see the result. So this is the power of Apache Kyuubi that's offered along with the charmed Apache Spark solution. So now, finally, we are going to talk about the Canonical observability stack and how the monitoring can be enabled for this cluster. To enable monitoring, it is really... Previous slide, please. To enable monitoring, it is simply straightforward, because we can simply edit the same Terraform JSON file or the variable file and simply change the deployed from no to bundled and provide the name of the model where we want to deploy the Canonical observability stack. And yeah, just with this, we can deploy the Canonical observability stack. How is this possible? This is possible because the same Terraform module also contains different applications that are part of the Canonical observability stack, all bundled within the same bundle. For example, you have Alert Manager, you have Grafana, Loki, Prometheus, etc. So now, since we already have edited that tfarts.json file, now we can simply apply it using Terraform. Let's see the Terraform plan. We can see that a new model called cost will be created with a bunch of applications like Alert Manager, Catalog, Grafana, etc. And on top of it, all of this will be automatically integrated together with our solution. And with just this integration or just this command, everything like the monitoring, entire monitoring setup will start working. Let's see whether the cost model has been created in Juzu. Yes, it has been created. Let's see the status of the cost model. You can see the different applications are being created. Fast forward, we can see all of these created and are in active and idle state. And also, if we see the Spark model, we can also see different applications like cost configuration, push gateway, etc. are created in the Spark module. This will effectively integrate our Spark module or the different application in the charmed Apache Spark bundle to the cost applications. So let's see how we can do monitoring using this setup. So as monitoring, we are primarily interested in two types of monitoring. So one is data engineer level monitoring, and one is system admin level monitoring. Next slide. So as a data engineer, you would want to know the state of your Spark jobs. You want to know what jobs have actually completed, what are in progress, the state of different executors, etc. And for this, Spark History Server can be used. Next slide. So the Spark History Server is also deployed as part of the same Kubernetes Terraform bundle. Let's copy the unit address and go to the browser, browse to 18,080 port of that IP address, and then see different information about that Spark job. For example, the timeline of different events, the different stages, the environment that was used to run this Spark job, the state of the executors, and different SQL statements that were executed. And if you are a system admin, there is Canonical observability stack that we just deployed that will help you see, different metrics, the state of your cluster, application metrics, application logs, etc. Let's see that. As you already see, we have already deployed the COS model and the different COS applications. COS means Canonical Observability Stack. There is traffic ingress controller. Let's run so proxied endpoints action on that, and then we can see different URLs. Let's go to the catalog URL. And inside Grafana, we need a username and a password to connect to Grafana, which can be provided to us by the Grafana app by running get admin password. Let's copy the password, go to the Grafana dashboard. The default username is admin, log into it, and then we have Grafana dashboard. Let's go to different dashboards. The Kyuubi dashboard is installed there by default. And if you go inside the dashboard, you can see, for example, different metrics, memory usage, the number of running Spark jobs or Kyuubi jobs, number of finished Kyuubi jobs, etc. Let's try to run the same aggregation query again. And while it is being run, let's see the state of our model or the namespace. We can see different pods like driver pod and executor pods are being spawned again. And once this aggregation query completes, let's go to Grafana dashboard and try to refresh these a bunch of times. Let's change the time frame, and we can see we have new metrics. For example, one running job, one finished job, etc. All of these in near real time. So with these, we finally have all of the charms in the bigger picture. We started from producing the data. We ingested it using Apache Kafka or charmed Apache Kafka. And then we use Spark to actually process that data using charmed Apache Spark. And we stored that data in the storage layer. We use charmed Apache Kyuubi to be able to query that data and then perform analytics. And finally, we integrated the entire solution with the Canonical Observability Stack in order to monitor the entire cluster and then see the metrics. This concludes the demo. Thank you.
All right. Thank you very much, Picapa. I see there are no questions in the channel. So while we perhaps wait and give the opportunity for everyone to ask questions, let me thank all the presenters and ask a very impromptu question. How was it, Paolo, Alex, and Picapa to work on the Spark solution as software developers here at Canonical? Someone needs to go first.
I can go first. This solution is such a fundamental part of the data scientist tooling that it's, as someone who was in the field before, it's really humbling to see the behind the scenes, how everything works, every single piece fit together to create a workload from end to end. I definitely appreciate way more what I used to take for granted when I was, actually using the technology.
Thank you.
I'll go next.
Okay.
So for me, the task is really interesting because primarily I love to work on charmed Apache Spark and charmed Apache Kyuubi because of Juju, and it makes all of the integration and all of the ecosystem come, in a really close together. And what I love about the Zuzu framework and the product we make is like the data engineers can actually focus their time on writing the actual jobs than having to, focused more on the administration of the cluster, and then connecting different bits together. All of those can be handled by Juzo, while you as a data engineer can write your Spark jobs.
On my side, the most let's say challenging things that we had to deal with was like to combine together all these different software, open source software together to make like a very nice and fully workable solution that really ran at scale. So it was a really nice experience. I mean, full of problems to solve and challenges, but when it's working, it's really a satisfaction for the whole team to see like all this work to put together in a nice way. Yes, we have a question.
Yeah, so I'll read it out loud. Maybe Paolo, you can reply if you'd like.
Sure.
Can Apache Kyuubi read from iceberg tables as well, or just Hive tables?
No. So the answer is simple. Yes, it can read from iceberg table as well. So there is like an iceberg integration between, in Kyuubi itself. So we can use and read from iceberg table as well. There are also example on the repository on how to do so if someone is interested in it.
Yes, absolutely. Thank you, Paolo, and thank you, everyone. I see there are no other questions, but I think it's nice to mention that we have a catalog out of the box for that. So, good to mention that. So, of course, the answer is yes, as Paolo said. I see there are no other questions, so I guess we can call it a day for today. So, thanks everyone for joining the webinar. Thank you again to all the presenters. And as a call to action, I encourage everyone to scan the QR code, look at the documentation, look at the release notes, and ultimately follow Bicalpa's demo. Go give it a go and come back to us and tell us what you think and if you'd like to deploy it somewhere. So thank you everyone again, and have a nice rest of your day.